Different grades of alcohol and butanol, 3:1, 2:2 and 1:3 is used. And finally, butanol 100% may be used. Dehydrated tissue thereafter is cleared with the help of xylene or different grades of alcohol xylene or butanol xylene in the ratio of 3:1 and 2:2 and finally 100% xylene. The machine automatically shifts the sample from one port to another after lapse of a fixed time. After the tissue is absolutely dehydrated and cleared, it is impregnated in a mixture of molten beeswax and paraffin wax at 50 degrees to 60 degrees centigrade for 12 to 24 hours. For this purpose, block cases are used. After impregnation, wax blocks of impregnated material are prepared using metallic L pieces. While preparing wax blocks, care is taken to pour sufficiently hot molten wax 60 to 80 degrees centigrade in empty block cubes so that wax may not congeal before the material is embedded in it in a vertical position. It is then allowed to cool sufficiently to make perfect blocks. Wax blocks are then fixed over block holders. Blocks are then trimmed around the centrally placed specimen so as to get a sharp projected rectangle or square. The specimen is now ready for cutting thin cross sections, which is done using rotary microtome, which has a sharp stable knife and a rotor. The block holder is mounted with the block clamps and is allowed to move up and down and forward using the rotor and micron forward distance controller over the very sharp edge of the knife so as to get very thin sections but of uniform thickness. The thickness of sections to be obtained is adjusted and the rotor of the machine is operated clockwise. A large wax ribbon containing very fine cross sections of the material is thus obtained. The ribbon is cut in small pieces and placed on the surface of warm water 60 to 70 degrees centigrade in a glass tub so as to unfold wrinkles in the material. Immediately after the wrinkles are removed, the sectioned material is lifted over the pre-glued glass microslides, which are thereafter air-dried and processed for dewaxing by using xylene. This is followed by hydration in steps using different grades of butanol and xylene, 1:3, 2:2 and 1:3. Butanol 100% and different percentage of alcohol, absolute alcohol 90%, 70%, 50% and 30% to remove all the glue used. This is followed by staining to differentiate various types of tissue elements present in cross sections. Usually, double staining is done using one stain after another. This is done by using fast green after safranin, hematoxylin after safranin, aniline blue after safranin, Bismarck brown after crystal violet. After staining, the tissue is again completely dehydrated and cleared and finally mounted under cover glass using Canada balsam or Euperol. Thus, permanent slides are made which can be retained for many years. Cross-sections are studied under the microscope for laying down standards for identification of samples on the basis of microscopy. In case of adulteration, comparative anatomical studies have to be made with anatomical features of the correct material. Diagrams are drawn using camera lucida or direct photographs are taken. In case of leaf drugs, besides other microscopical features, quantitative estimation has to be made for stomatal index, palisade ratio, vein islet number, etc., which differ from species to species. Stomata most often are deciding factors. They may be present on both sides or on one side. On the upper side, while absent on the lower, or on the lower side, while absent on the upper. For the purpose, leaves are made transparent using lactic acid or concentrated aqueous solution of chloral hydrate. Quantitative estimation is done using camera lucida. Stomata may be of different types: anemocytic, parasitic, diacytic, anisocytic. Scanning electron microscopic studies are done in cases where differentiation has to be made on the basis of difficult morphological features. For scanning electron microscope with a resolution of 45 degrees Armstrong and magnification up to 1 lakh normally are used. For the purpose, sample has to be prepared using specialized techniques. The sample is first revived using warm water and then fixed by double fixation method using 0.1 to 0.5% solution of osmic acid, followed by 1 to 2% solution of glutaraldehyde. It is subsequently subjected to dehydration using amyl acetate and critical point dryer where liquid carbon dioxide plays an important role. And finally, coated with a thin layer of gold to make the surface conductive. The sample so prepared is fixed on stubs and placed over the port inside the closed scanning chamber, where a vacuum is created. The moment light is switched on, an electronic beam starts falling over the conductive surface of the sample and generates signals which finally produces an image on the monitor. Homoeopathic Pharmacopoeia Laboratory is maintaining a medicinal plant garden to make available plants needed for establishing standards and comparative studies. The laboratory maintains 50 to 100 plants throughout the year. Important medicinal plants maintained worth mentioning are Rus toxicodendron, Rus glabrea, Fraxinus americana, Cineraria maritima, etc. For the purpose, the laboratory procures germplasm from all over the world. Artificial germination techniques including tissue culture is adopted for propagation and cultivation of plants in the herb garden wherever needed. After the raw drug is identified and standards laid down on the basis of morphological and microscopical characters, it is subjected to different methods of extraction to prepare mother tincture for phytochemical and chemical analysis for identification of its active ingredients and their qualitative and quantitative estimation. After pharmacognostic characterization of herbal and animal drugs, their moisture content is determined using infrared moisture balance or by using the oven. The plant moisture plays an important role in the formulation of all mother tinctures. Mother tincture, the initial product from the plant or animal source, is prepared mainly by two methods. Mother tincture of dry drug by percolation and mother tincture of fresh drug by maceration. Percolators are made of either neutral glass or stainless steel. The plant material is ground to powder and packed into the percolator and is extracted with ethyl alcohol water mixture as per the method prescribed. Maceration is done in steel containers and requires 2 to 3 weeks' time. Drugs from chemical sources are prepared by trituration. Homeopathic potencies are raised in decimal and centesimal scale using 90% alcohol in a dust-free atmosphere. Generally, it is done under aseptic conditions using laminar flow benches. The organization is laying down standards of mother tincture in respect of alcoholic content, pH value, total solids, weight per ml maxima, and identification. Mother tincture and lower dilutions up to 6x are subjected to chemical analysis, including testing for identity of active ingredients through TL